Hello students, welcome back to my YouTube channel. In this video, we'll be discussing some questions about enzymes. Now, before starting with the questions, we'll learn a few terms about enzymes and their activity. So, first of all, this is a graph of substrate concentration versus reaction velocity. So, the first term that we'll be looking at is Vmax, that is the maximum initial velocity at any given enzyme concentration. Then units of enzyme activity. 1 international unit equals 1 micromole of substrate used per minute. Now, specific activity. It refers to units of enzyme activity per milligram of protein. Now, turnover number reflects the number of molecules of substrate converted per second per enzyme molecule at saturating substrate concentrations. So the difference between specific activity and turnover number is that one measures enzyme activity with respect to the amount of protein, and the other measures the enzyme activity with respect to the number of enzyme molecules present. Now, Michaelis constant Km, it is the substrate concentration at which the reaction velocity will be half of the maximum velocity. And finally, catalytic efficiency, that is kcat by km. It is useful for comparing substrate specificity for enzymes with multiple substrates. A higher kcat by km ratio means the enzyme has high specificity for that particular substrate. Now, moving on to questions. So, question 1 is uh, some properties of enzymes are listed in the column X and their kinetic expressions are listed in column Y. So column X has 4 enzyme properties: specific activity, turnover number, Michaelis constant, and catalytic efficiency. And column Y has 4 expressions: kcat by km, substrate concentration at which V is equals to Vmax by 2. Third is Vmax per moles of enzyme, and fourth is Vmax per protein concentration. So we just learned these terms. So if you remember all the definitions, you can easily get this answer. We'll start from the left. So specific activity means Vmax per protein concentration. So if we look at the options, just from this single detail, we can narrow it down to option 3. And looking at the other terms, turnover number means Vmax per moles of enzymes, and Michaelis constant means substrate concentration at which V is equals to Vmax by 2. And in the end, catalytic efficiency is the ratio of kcat and km. So the correct answer is option 3. Now moving on to second question. If 10 microgram of pure carbonic anhydrase catalyzes the hydration of 0.3 gram of carbon dioxide in 1 minute at 37 degree at Vmax, then what is the turnover number of carbonic anhydrase in units of per minute? And molecular weight of carbonic anhydrase is 30,000. So first, as per the definition, kcat that is the turnover number, is number of substrates utilized per minute divided by number of enzyme molecules. So to get the number of substrate molecules utilized per minute, we have one number that is here, zero point 0.3 grams of CO2. And to calculate the number of molecules of CO2 present in zero point 0.3 grams, we'll need the molar mass of CO2, which is 44. So this will give the moles of CO2 to be 6.82 into 10 raised to minus 3 moles. Now, similar way, the number of enzyme molecules. So we have the amount of enzyme that is 10 microgram and its molar mass is 30,000. So using these numbers, we'll get the moles of carbonic anhydrase to be 33 into 10 raised to minus 11 moles. Now, putting both of these numbers in the equation for the kcat, we'll get the result 2.06 into 10 raised to 7. So from this result, the correct answer is option 2. Now, moving on to question 3. An enzyme has been found to efficiently catalyze the following reaction. A is converted to B with the rate constant Kf, and B is converted to A with a rate constant Kr, F for forward reaction and R for reverse reaction. K equilibrium, which is equilibrium constant, is the ratio of forward and reverse rate constants. Now, which one of the following parameters will be increased over the uncatalyzed reaction by the enzyme? Our options are: first, K reverse; second, K equilibrium; third, 1 by K reverse; and fourth, 1 by K equilibrium. Now, to answer this, we have to take a look at what is the difference between catalyzed and uncatalyzed reaction. Now, as you can see from this image, when using a catalyst, it lowers the free energy of the transition state. That means the transition state for a catalyzed reaction is more stable compared to uncatalyzed reaction. So this lowering of the free energy of the transition state will mean that both the rates for forward and reverse reaction will be increased. And because both of the rates will be increased in similar amounts, the equilibrium constant will not change. So from this information, our correct answer will be first, K reverse, because equilibrium constant is not changing and K reverse is increasing, which means that 1 upon K reverse will be decreasing. So that means that option 3 is wrong. Option 2 is also wrong because equilibrium constant is not changing. And if equilibrium constant is not changing, that means 1 by equilibrium constant will also not change. So the correct answer is option 1. Now, moving on to question 4. At what range of substrate concentration will an enzyme with a kcat of 30 per second and a Km of 0.005 molar will show 1/4 of its maximum rate? Now, to get this answer, we'll need few equations. First, we know that Michaelis constant Km is the substrate concentration at which V0 equals half of the Vmax. Now, in our case, Michaelis constant is 0.005. Now another number that we are given is kcat, which is 30 per second. Now we need to find the substrate concentration at which the reaction velocity will be 1/4 of the Vmax. So we'll use this equation which states that reaction velocity equals Vmax into substrate concentration divided by substrate concentration plus Km. Now in our case, the reaction velocity is 1/4 of the Vmax. So we have made that substitution, and Vmax equals Kcat into enzyme concentration. Now we'll be assuming enzyme concentration to be a single unit, and it will convert Vmax to Kcat. Now putting all these values, we'll get this equation, and by solving it for substrate concentration, we'll get something like this. On the left hand side of the equation, the denominator 4 will go to the right hand side, and the denominator of the right hand side will go to the left hand side for cross multiplication, and we'll get the equation 30 into substrate concentration plus 30 into Km equals 120 into substrate concentration. When we simplify this and put the value of Km, which is 0.005, we'll get 30 into 0.005 equals 90 into substrate concentration. Now solving this for the substrate concentration, we get the answer 1.67 into 10 raised to minus 3 molar, which falls into the range of option 3. So our answer will be option 3. Moving on to question 5. If a 0.1 molar solution of glucose 1-phosphate is incubated with a catalytic amount of phosphoglucomutase, the glucose 1-phosphate is transformed to glucose 6-phosphate. At equilibrium, the concentrations of the reaction components are following. The concentration of glucose 1-phosphate at equilibrium is 4.5 into 10 raised to minus 3 molar, and concentration of glucose 6-phosphate at the equilibrium is 9.6 into 10 raised to minus 2 molar. Now, what would be the calculated values for K equilibrium and free energy change for this reaction at 25 degrees Celsius? Now, equilibrium constant is derived from the concentration from the ratio of concentrations of product and substrates at equilibrium. So as we are provided both the numbers, we'll just put them into the equation and we'll get the equilibrium constant to be 21.3. So from this first half of the answer, we can see that we only have to focus on options 2 and 4, which depict the equilibrium constant between 21 to 22. Now, calculating the free energy change. So the formula for that is free energy change equals minus RT log E to equilibrium, log E of equilibrium constant. In this equation, R is gas constant, which has a value of 8.314, and T is absolute temperature, which means temperature in Kelvin. So when we convert 25 degrees Celsius to Kelvin, we'll get 298. and we already have the value of equilibrium constant. Now putting all of the values in the equation, and by solving it, we get the free energy change to be negative 7.57 kilojoule per mole. So which means the correct answer is option 2. Moving on to question 6. For the coupled reaction given below, the equilibrium constants for equation 1 and 2 are 270 and 890 respectively. Reaction 1 is glucose 6-phosphate plus H2O gives glucose plus free phosphate. And reaction 2 is ATP plus glucose gives ADP plus glucose 6-phosphate. Now, from this, we have to calculate the standard free energy of hydrolysis of ATP at 25 degrees Celsius. Now, for coupled reactions, the net change in the free energy will be the free energy change for both the reactions, that is reaction 1 and 2. Now, as we saw in the last question, the equation for the change in free energy is negative RT log E equilibrium constant. Now, first we'll calculate the free energy change for both the reactions. For reaction 1, by putting all the values in the equation, we get the free energy change of negative 13.8 kilojoule per mole. And doing the same thing for reaction 2, we get the free energy change of negative 16.8 kilojoule per mole. Now, when we add both of these, we get the final free energy change to be negative 30.6 kilojoule per mole. Now, this falls into the range of option 3, that is negative 30 to 32 kilojoules per mole. So that will be our answer. Moving on to question 7. A propionate kinase enzyme utilizes two substrates, propionate and acetate, with Michaelis constant for propionate being half that of acetate. Which one of the following options about the rate of the reaction at very low substrate concentration is correct? Our options are: the rate of propionate utilization is half that of acetate. Option 2 is the rate of propionate utilization is double that of acetate. Option 3 is the rate of propionate utilization is equal to that of acetate. And option 4 is the rate of propionate utilization is 4 times that of acetate. Now, we know that Michaelis constant is the substrate concentration at which reaction velocity is half of the maximum reaction velocity. And Michaelis constant for propionate is half of the Michaelis constant for acetate. Now, if we look at this rough diagram, we can see that the enzyme will be saturated with propionate at much lesser concentration than it will be saturated with acetate. So we can say that the rate of propionate utilization will be double that of acetate. Because the Michaelis constant for propionate is half of the Michaelis constant for the acetate. So at half the substrate concentrations, we'll get closer to Vmax for propionate. So the correct answer is option 2. The rate of propionate utilization is double that of acetate. Now, coming to the final question. What is the V0 by Vmax ratio for an enzymatic reaction when substrate concentration is 3 times Km and 9 times Km respectively? So as we saw in the one of the earlier questions, the equation for reaction velocity is Vmax into substrate concentration divided by substrate concentration plus Michaelis constant. Now first we'll divide both sides by Vmax to get our ratio. Now for the first case where substrate concentration is equal to 3 km, we put in the values and we simplify the equation and we'll get the ratio to be 0.75. Now from this point only we can say that the correct answer is option 4, but we'll still solve for the other case as well. We'll do the same thing again. We'll put in the values and we'll get the ratio to be 0.9. So the correct answer is option 4, 0.75 and 0.9. Now, if you find any of these questions difficult to understand, let me know in the comments. I'll try to explain them again in a better way. Thank you for watching.